Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on simultaneous equations. So simultaneous means at the same time. What we're going to be looking at here is solving two equations with two pronumerals at the same time. We want a solution that makes both of them true at the same time. So let's say we had an equation like this, x plus y equals 5. So that's one equation with two pronumerals. Asking you to solve it, you probably get a bit confused because there are infinitely many solutions. I can literally choose any value I want for x, and each value of x has a different value of y. So I could choose the solution 1, 4. Remember, we always write x first and y second. We're writing it like a point. So that's a solution to this equation, because if I substitute x equals 1, y equals 4, I get a true statement. 1 plus 4 does equal 5. There are heaps of other ones I could choose. I could choose x equals 2, y equals 3. I could choose x equals 8, y equals minus 3. There are infinitely many solutions. So we don't have enough information here to come up with just one solution. What I need is a second equation with x's and y's in them in order to solve this simultaneously. So let's say I also know that y equals x plus 3. So now I have two equations and two pronumerals, x and y. It turns out that when I have a situation like that, I usually get one and only one solution. So this equation up top had infinitely many solutions. This equation at the bottom, just by itself, has infinitely many solutions. So I could have the solution x equals 0, y equals 3. I could have the solution x equals minus 5, y equals minus 2. I could also have the solution x equals 1, y equals 4. Both of these equations have infinitely many solutions, but there's one solution that solves them both at the same time, and that is the solution to the simultaneous equations. So the solution to these equations, the solution that solves both at the same time, is x equals 1, y equals 4. So that's what we're actually looking for with simultaneous equations. A value for x and a value for y that makes both equations true at the same time. So how do we actually go about this? Well, let's look at that on the next slide. Please pause and copy this down if you need. So our plan of attack is to substitute one equation into the other. So let's look at how we would actually get the solution we did on the previous slide. So the two equations were x plus y equals 5 and y equals x plus 3. What you do is you take the equation that has x or y as the subject and substitute it into the other one. So here in this second one, y is the subject of the equation. So we're substituting into this one. So what that means is I take my first equation, I'll rewrite it down here, and I'm going to change y to x plus 3. So the reason we're doing this substitution, we don't know how to solve an equation with two pronumerals, but by substituting, now you can see I've got an equation that has only one pronumeral. We know how to solve them. We're awesome at solving them. So x plus x is 2x. So I just solve this like normal. I subtract 3 from both sides, and then I divide by 2, and I get x equals 1. I'm not done here because I need to find the y value. So after I found the x value, I substitute into either equation, this or this, to find y. So if I substitute into the bottom one, I just get y equals 3 plus 1, which is 4. And that's how I got my solution, x equals 1, y equals 4. So I'll rub this out. Let's do another example. So let's look at these two equations on your screen. Once again, you have two equations and two variables. We want to find a value for x and a value for y that solves both equations at the same time. So we substitute one into the other. Because x is the subject of the equation here, we're going to substitute that into the second equation. So I'll rewrite my second equation. So what I'm going to do is rub out x, and I'm going to replace it with 2y plus 7. So I need brackets here because it's 4 times everything. 4 times x minus 3y equals 18. Now we've got an equation with only one variable. You know how to solve this. So first step, we will expand the brackets, and then we will collect like terms. We get 5y plus 28 is 18. Subtract 28 from both sides. Divide by 5. I get y is minus 2. So again, we're not done. We've only found one variable. So to find x, I can just take this equation here, and I can substitute y for minus 2. So x is 2 times y plus 7, which is 3. So therefore, the solution to this equation, x always gets written first. It's 3 minus 2. X equals 3, y equals minus 2 solves both equations at the same time. All right, let's have a look at doing a worded problem using simultaneous equations. So at the canteen, 2 burgers and 3 cans of Coke cost $15.80 all up. And we know each burger costs $3.40 more than each can of Coke. So how much does each item cost? So now we're looking for two things. We're looking for the cost of a burger and the cost of a Coke. So what I told you in the previous video with equations doesn't apply here. Now we want to define two variables and two equations. So we start off by letting x and y be the things we're trying to find. So I'm going to let x equal the cost of a burger, and I'm going to let y equal the cost of a Coke. Of course, it doesn't matter the order. It doesn't matter if you let y be the burger and x be the Coke. It really wouldn't change at all. So we've got two variables. Now, to find what they are, we can't have just one equation. We need two equations. So the first bit of information, 2 burgers and 3 cans cost $15.80. I want to rewrite that using only mathematical symbols. So 2 burgers plus 3 Cokes gives me $15.80. I need another equation. So the next bit of information says each burger costs $3.40 more than a can of Coke. So what that means is burger equals can of Coke plus $3.40. Now I've got two equations. It looks just like the simultaneous equations we solved on the previous slide. So I'm going to substitute this equation into the first one. I'm substituting this one because x is the subject of the equation. I'm going to rewrite this first equation, 2x plus 3y equals $15.80. And now I'm going to replace x. I'm going to rub it out, and in its place, I'm going to write y plus $3.40. You know how to solve these equations. Expand the brackets. Then we collect like terms, and we solve like normal. You subtract $6.80 from both sides, and then you divide by 5. I get y equals 1.8. Of course, that means in this context $1.80. So I found out what the cost of a can of Coke is. I need to find the cost of a burger. So I can get it from this equation. The Coke costs $1.80, so the burger costs $1.80 plus $3.40, which gives me $5.20. So once again, a worded problem should be answered with a worded answer. So we just write a worded answer that answers the question, how much does each item cost, and shows you know what you're talking about. So we found that each burger costs $5.20, each can of Coke costs $1.80. So the first student to mention this video and this particular example, you can have a can of Coke, just to keep you watching. All right, this has been the luckiest maths teacher in the world. Thanks for watching. Have a great day.